The symmetric key encipherment can be done using the modern block ciphers. Each plain text block from the receiver is going to be recovered by the bob. So here we have the diagrammatic representation of the ECB mode where we use the n bits. What is this ciphertext stealing is? We use this technique. Hello students, welcome to the next session of network security. I am Dr. Soumyashri from Department of Computer Science, Vidhyaashram, first grade, college. Let's start this session with a new unit, that is the third unit in the network security subject. Okay, the third unit starts with the brief study of the use of the block ciphers and the stream ciphers. What are the different methods of encrypting and decrypting the plain text in the block ciphers as well in stream ciphers. Okay. Along with that, we will look into various methods of the encryption in the third unit. Let's start this session. The first thing we need to know is the symmetric key encipherment, or the block cipher as well as the stream cipher belong to the category of symmetric key ciphers, isn't it? The agreed upon key ciphers, right? The symmetric key encipherment can be done using the modern block ciphers. Till now, in the previous unit, we studied so many cipher methods, symmetric cipher methods, block and the stream cipher methods, which were the traditional methods, isn't it? But they are not secured when compared to the today's cipher. With the today's technology, the traditional ciphers are used this. That means we have to use the modern block ciphers for encipherment in the network security. Okay, the modes of operation for encryption and decryption has been devised to encipher the text of any size by using DES or AES. DES uses 64 bits of plain text it is going to use, and AES is going to use 128 bits of key as well as plain text block, isn't it? Now, you can use DES or AES to encrypt and decrypt any message of any size. That means message is not of a single size, isn't it? It is not fixed that it always has only 64 bits of plain text, and it is even not mandatory that if AES cipher is to be used, the message must be always contain 128 bits. You can have more number of bits as well as less number of bits. Let's know how does this DES and AES are going to be used in case of the varying length of the message. Okay, we have 5 types of modes of operation to encrypt and decrypt in the block cipher, mainly in block cipher, not in the stream cipher. Okay, the first method is electronic codebook method. Second is called cipher block chaining method. Third is the cipher feedback method. Fourth is output feedback method. And fifth is the counter method. Okay, so 5 methods are used in block cipher to encrypt as well as decrypt a varying length text. Okay, now let's check each one of them in detail. The first is the ECB mode, or the electronic code book mode. In this, the simplest mode of operation, this is the simplest mode of operation, which is called as the ECB mode or electronic code book mode. Okay, the encryption method is like this, as we show in the expression. It uses multiplication of the encryption key with the plain text character, and decryption will be plain text of I length will be equal to multiplication of decryption key into the ciphertext character. Okay, key character and ciphertext character. We are using this E-code book or electronic code book ECB mode to encrypt as well as decrypt. So here we have the diagrammatic representation of the ECB mode where we use the n bits. So that means if the length of the message or size of the message is more than the fixed bits or 128 or 64 bits, the bits will be padded to get the n number of bits. Okay, so we have plain text 1 with n number of bits, block of n bits. The encryption algorithm executed and n bits only is obtained with a ciphertext block of C1, C2 up to Cn. The last bit or last block equally distributed. If the last block contains less or more number of bits than the specified bits, if it is more, it will be truncated. If it is less, you will be adding extra characters, bogus characters to the message. Usually it is not truncated but is added. Padded means it is covered with certain number of bits. Suppose if the block has 10 characters in a block and if it contains 66 characters, you will make 6 block of 10 characters each. 10 characters. Last block has only 6 characters. So now what we can do is we can add 4 bogus characters to make again the last block as the 10 characters. Total of 10 characters will be there in the last block also. Okay, so text will be padded. Characters will be padded in case of the electronic code book mode. In the same way, decryption is done. N number of bits, decryption algorithm with the key, then the plain text of n bits will be calculated in the ECB mode. Okay. The example you can give is, it can be proved that each plain text block at the receiver's site is exactly recovered at Bob's site because same block is encrypted with same characters and is going to reach the receiver, and same block is decrypted back to the plain text. Okay. Each plain text block from the receiver is going to be recovered by the Bob without much failure because encryption and decryption are inverse of each other. Exactly opposite task is going to be done in both the process. So you can easily get back the plain text from the ciphertext. Okay. Another thing is, why do we call this as electronic code book mode is, one can pre-compile 2 to the power of k code books. Suppose key set is 28 key sets we have. We can have 2 to the power of 28 pre-compiled, which is already tested and approved. Pre-compiled code books, one for each key. You will have that many blocks in which each code book has 2 to the power of n entries. What is the number of bits plain text? That much 2 to the power of n entries will be there in 2 columns. Okay. So each entry can list the plain text, each entry and the corresponding ciphertext block. There will be one column of plain text and another column of ciphertext. Both can be entered or both can be stored details in the code book in the form of a code book. Okay. However, if k and n are large, if number of key set and number of plain text characters are large, the code book would be far too large to pre-compile and maintain. So this concept is taken from the traditional cipher. When cryptographic method was in a childhood or infant stage, then a code book was maintained to get, if this is a plain text, what may be the ciphertext. If this is the plain text, what may be the ciphertext. So this, like this, list would have been maintained. Same concept is implemented here with the code book concept, with two columns, having one column entry with plain text and another column's entry with the ciphertext. That is why the mode is called as the electronic code book. It is not the physical code book, it is the electronic code book mode. Alright. Another thing is, assume that Eve works in a company. So example what we are given is, if an attacker in a company is working on hourly basis and the monthly payment is very much low, what she can do is, she knows that company uses the blocks of information for each employee. Each employee's details are stored in the form of a block, in which the 7th block is the amount of money to be deposited in the employee's account. The database details are taken in the form of a table or a list, where one list contains the employee number, next column contains the employee name, then employee designation, employee basic salary, DA, TA of the month. Replace the block with the information about her payment. What she'll do is, she'll replace the other six columns of some other employee, permanent employee or full-time employee, with her details. What now happens is, the amount that has to be deposited to the permanent employee will be deposited to the attacker's account. Okay, have the copy of the block with the information about the payment of a full-time colleague. Payment will be of the full-time employee, but the name will be of attackers. Okay, so what does the Eve will get is, each month Eve can receive more money than what she was offered or what she was used to get before this stealing. Okay, this is how you can get the block. Okay, along with that, when you check with the security issues, patterns at the block level are preserved, because same block is continued for the ciphertext also. If first block has that much text, those number of text or repeated text will be repeated in the ciphertext also, with the same series of block number in the ciphertext. Okay, the patterns will be preserved and you can use that pattern for the next message. If the same salary pattern is maintained for the next month, she can use those details to replace once again with the employee details. Okay, along with that, the block independency creates opportunities for Eve to exchange some ciphertext block without knowing the key. Suppose if 1357 in the plain text are encrypted, the block, ciphertext block will be 1357 only. So if the attacker gets to the ciphertext of 1357 and can predict the text or can predict the plain text, she can get into the entire message with the help of these 4 blocks, isn't it? So they are independent. Blocks are not going to exchange and they are not dependent on any other. If the first block plain text is encrypted to the first block ciphertext only, there is no exchange of the blocks. So attacker can easily access the block of the code book easily. The error propagation in this is, a single bit error in transmission can create errors in several. If one bit is changed in any one block, the entire ciphertext will be changed. However, the error does not have any effect on the other blocks. If one block is there, if one block's bits are exchanged or changed, it will affect only that block, not the other blocks. But the block where bits are exchanged, the entire data will be manipulated or entire data may get modified. Okay, so this is about the first mode of operation. In this, we have a concept known as ciphertext stealing. What is this ciphertext stealing is? We use this technique which can make it possible to use ECB mode, that is electronic codebook mode, without padding, without adding extra bits. In this technique, the last two plain text blocks, we have 2 to the power of n minus 1, that is plain text of n minus 1 and plain text of n, that is last and the previous one, are encrypted differently. So the encryption method that we use for the last and the previous method will be different and out of order. We use different method to encrypt that, as we shown below, assuming that p of n minus 1 has n number of bits and p to the base n has m bits. That is, if we have 5 blocks, the first, 4th and the 5th block will be encrypted differently by considering this is p of n minus 1 has n number of bits and p of n has m number of bits. Okay, where this number of bits in last block will always be less than the previous block. Okay, so like this we can use x equals, the different method is used, encryption key into p of n minus 1 gives rise to ciphertext of n, that is the last bit, with head m, that is the leftmost bits of the last block will be considered in this block, whereas this will be the plain text, that is the rightmost bit. During decryption, rightmost bit will be considered, because in encryption, leftmost bits of the previous, the last block will be considered, whereas in decryption, the rightmost bits of the n minus 1th block will be considered, because the encryption and the decryption are reverse procedures. Okay, the application of the electronic codebook mode is not recommended for encryption of the messages more than one block. Okay, that means one area where the independency of the ciphertext block is useful is where records need to be encrypted before they are stored in database. They are not going to be stealed. So it is going to be database, it is going to be stored in database, but in an encrypted form. In that case, you can make this use of the independent blocks or decrypted before they are retrieved. Not passed on the network, but is passed on the network and is stored in the database. That means there are no receivers, there are no attackers involved in the middle of the data transmission. So in that case, it is going to be propagated to a application instead of a receiver. In such a case, you can use this ECB mode. Another advantage of this mode is that we can use the parallel processing, because we are parallelly encrypting the blocks, which can create a huge encrypted database. Okay, the next method that we can follow is the Cipher block chaining mode. In this, each plain text block is exclusively ORed or XORed with the previous ciphertext block. Okay, it depends on the previous round's output. Okay, before it is encrypted. We have the diagrammatic representation of the CBC mode. Here we have n bits. You will be performing the exclusive OR with an previous block. So previous block is added with the encryption to get the ciphertext. In this, reverse process will be done. During decryption, the result of the previous block is XORed to get the plain text. Okay, so we are using the previous block or output of previous block XORed with the current plain text block. Okay. So the encryption and decryption the procedure is like this. What about the first block is, here you can observe we are using an initialization vector. There will be round key or an initialization vector having n number of entries which will be XORed with the first block of plain text. Okay. Here we use the first block will use the initialization vector for XORing, and the next blocks will use the encryption key along with XOR result of the plain text with the previous ciphertext block. Decryption will be reversal of that. It can be proved that each plain text block at the receiver side or the sender side is recovered exactly at the receiver side. What has been sent by the sender is received in exactly same form at the receiver's system, because encryption and decryption are inverse of each other. Again, the same concept. Since both are inverse of each other, you can easily implement the encryption and decryption methods. For the first block, we make use of the initialization vector. So the initialization vector should be known by the sender and the receiver. So sender and receiver must agree upon the initial set of bits that we are going to be used for XORing with the first plain text block. Alright, when you look at the security issues in this, the patterns at the block level are not preserved. We are not going to pre-compile the blocks, are not preserved. If the first m blocks in two different messages are equal, if the repeated messages have first m number of blocks and they found that they are equal, they are enciphered into equal blocks unless different IVs are used. You will get same encrypted block if you use same initialization vector. Only when you use different initialization vector for the equal looking blocks or equal bit blocks, then you can get exactly the strong ciphertext block. Otherwise, if the initialization vector are same and the first m blocks are also equal, then obviously you will get same n number of blocks when the ciphertext is created. Okay. The recommended use of timestamp is used based on the time the IV initialization vector will be recreated or reset by the algorithm to get different set of blocks. Okay. When you check the error propagation in this, in CBC mode, a single bit error in ciphertext block which needs to be XORed with the next one during the transmission may create error in most of the bits, because in CBC mode we don't have independency, block independency. Each block depends on the result of the previous block, isn't it? If one bit in the one of the block is affected, it affects all the consequent blocks in the plain text. Okay. When you look at the applications of the CBC mode, again, the application is in the parallel processing is not possible because of the dependency over the previous block. CBC mode is not used to encrypt and decrypt random access file records, because each block will depend on the previous block. You can use it with this for random accessing of the files because of the need to access the previous records. If you check for a single block, it is not independent. It depends on the previous. Now we have to check for the previous block. Again, it is not independent. Now we have to go for the previous block. Like this, it will become the redundant work, which increases the work of the receiver to decrypt the blocks. So CBC mode are generally used for authentication with the previous experience. So if iris have to be matched, the iris details are considered as a block. It depends on the previous block which is already stored. My iris configuration or iris, how it looks, what is the angle of the lines in the iris, how it is organized in the iris, everything, the lines and the angle of the pupils, everything will be captured with the previous experience. So this previous experience is added with the current to match. In such cases, you can make use of the CBC mode for the authentication as well as with the fingerprints. Okay, fingerprints must match with the previous one, isn't it, which is already stored. In such a case, we can use this mode of enciphering and deciphering. When you look at the ciphertext stealing in this, the ciphertext stealing technique described in the previous mode can also be applied to CBC mode as it is shown here to pad the blocks. Okay, the head function is same as described in the ECB mode. Okay, the pad function inserts the zeros instead of bogus characters. It inserts only the zeros. The next thing is the cipher feedback mode. What happens in this? How does encryption and decryption is done in block cipher is, we need to use the DES in some of the situation. We need to use the DES or AES as the secured ciphers with the varying number of size or varying size of plain text. But the plain text or ciphertext block size are needed to be smaller than 64-bit or 128-bit. You can't have more number of less number of blocks with more number of characters. This time the situation is different. You need to have more number of blocks with less characters. In that case, you can use the cipher feedback mode. In this, there will be the initialization vector involved, n bits. We have the key, we have the plain text, then it will be encrypted with r bits. Cipher feedback mode, instead of encrypting and decrypting, encrypting the plain text and decrypting the ciphertext, we are going to encrypt and decrypt the contents of the shift register. Okay, we use shift register in case of cipher feedback mode whenever we use either DES or AES. If number of bits is smaller, instead of accessing the plain text and the ciphertext, we are going to use those blocks or store those blocks in the shift registers, and the blocks that are used in shift register are used to encrypt as well as decrypt. So here we have the shift register content with n bits with an initialization vector. The encryption algorithm is applied on the shift register content and produces a temporary block with k number of bits. We'll have r bits XORed with the previous first stage or first block's ciphertext, and you are going to insert that into the next block, or you are going to XOR that with the next block. In this, we are going to use r bits of shift register content with r bits of plain text. It will be XORed and you will get a new set of r bits, which is a ciphertext, which is going to be encrypted with the contents or which are to be stored in the shift register for the next block. Again, n bits will be taken for encryption algorithm. You will get temporary block of ciphertext. So the shift register ciphertext with r bits will be added with the key 2 and r bits of plain text. Then you will get another r bit set which is to be used or which is to be stored in the shift register for next encryption. Like this, each time the content will be added to the shift register. Instead of directly accessing the plain text and the ciphertext, the contents in the shift register are encrypted and decrypted, because shift register can accommodate less number of characters or less number of blocks in the shift register. So we can accommodate the lesser bits block in the shift register, and you can use the same algorithm for the contents of the shift register. Okay. How do you perform the encryption and decryption process in the Cipher feedback mode? It is called a Cipher feedback mode because feedback is taken from the previous block, isn't it? So it depends again on the previous block, like the CBC mode. Now we have the encryption as CI equals PI XORed with select left, that is left bits of the shift register. If you know about the functioning of the shift register, only the MS or most significant bits are considered from the register. Select left R bits with the key and shift left R bits from the shift register. Plain text, R bits of plain text and R bits of shift registers are used and XORed with the plain text of the current block to get a ciphertext. Decryption will be reversal of that CI XORed with select left R with the decryption key. This is decryption key, or you can use the same key which is used in the encryption, and shift left R with SI1 and CI-1 till the previous block. So contents will be concatenated to get the plain text and the ciphertext. What are the advantages of the CFB mode or Cipher feedback mode are? It does not need padding. It does not need to add the extra zeros or bogus characters, because the size of the block R, the block to be encrypted, is normally chosen to fit the data unit or the shift register to be encrypted. It depends on only the capacity of the shift register, and bits will be only that much. The block will be set for only that much character a shift register can accommodate. The system does not have to wait until it has received a large block of data. It can encrypt the size of the block regardless of how many characters the block has. So it need not to wait till it becomes 64 bits or 128 bits before starting the encryption. Alright. What are the disadvantages of the CFB mode? It is less efficient. Why it is less efficient than the CBC and ECB? Because it needs to apply the encryption for each small block of size R. So size R may be only 4 characters, size R may be 20 characters, R may be 30 characters, or may be 100 characters. It is varying with each execution. So even if you have only fewer characters in the shift register, you have to use the encryption algorithm and decryption algorithm to perform the encryption and decryption of the blocks. Okay. Now, the discussion is all about if we use the CFB mode in a stream cipher. Okay, what happens is we have the insecure channel. Even though it a block cipher, since it depends on the previous one, it will become serial one, isn't it? It will become a stream. The text, the ciphertext from this is again stored into shift register. Again it is combined with another R bit of plain text. So it is combining with the previous block. If you have the block B1, B2 coming to the second step, you are adding B3 and B4 from the next set. So you will add B3 and B4, block 3 and block 4. Again in third stage, you may get block 5. with number of characters. That means you are serially in stream, you are transferring the ciphertext to the receiver. So you have a series of blocks, isn't it? Block is not interchanging. They are series which are dependent on the previous block. So this can be termed as stream cipher. Stream block, both the concepts are there in the CFB mode of encryption and decryption. So here we have the stream cipher method of how to get the CFB as in a stream cipher. Okay. When you look at the security issues in the CFB as a stream cipher, the patterns are not preserved for the next execution because the attacker or the adversary can easily get or guess the plain text if you get certain series of the ciphertext. Since it is a stream, when you get certain blocks, you can guess the other blocks. What may be the content of the other block? It can be easily guessed by the adversary. So the patterns are not received in the or preserved in the CFB when it is used as a stream cipher. The initialization vector should be changed for each message. Otherwise, the pattern or the ciphertext received may be same as that of the previous message. The adversary or the Eve attacker can add an extra or some ciphertext block to the end of the ciphertext stream. So it is easier to concatenate since we use concatenation operation in encryption as well as decryption. If you look at the thing, how do we use the CFB mode? Here you can observe that you are concatenating the ciphertext from the previous block. So you can easily add some ciphertext block concatenated with the previous one, which can change the format of the block, format of the entire message, or can add some bogus information or virus unwanted programs to the message, which can corrupt the entire message before it is received by the receiver. When you look at the error propagation in the CFB mode, the error propagation when compared a single bit error in ciphertext block CI during the transmission creates a single bit error in plain text block of PI. So there will be a single bit error. However, most of the bits in the following plain text blocks will be erroneous. Okay, since it is considered as a stream cipher, one bit interchange or one bit change in the text ciphertext will make all the repeating blocks, all the blocks behind it has the erroneous bits. Okay, where do you apply this CFB mode? Where are you going to use this CFB mode? This mode can be used to encipher blocks of small size. As we said, for smaller size blocks, we can make use of CFB mode, such as characters or bit at a time. If you want to propagate fewer bits of blocks or fewer bits of data at a time, you can make use of the CFB mode of encryption and decryption. Thank you.